this is Dickie, once again, the former spokesman for the American Cultural Tradition and or American Cultural Memory Complaint Department, and the current head and or chief and or director head chief and or chief head director and or head director chief of the Stochastic Intelligence Agency. Yes, and once again, I am here in a, what? Anyone? Mitch? No? I am here in a quantum wave function. Yes, I am. And also inside this representation of a box, which we're going to get to today. And I'm here once again with Mr. Mitch McConnell, who is either the oldest living U.S. senator, or perhaps just a simple thought experiment. How you doing today, Mitch? Okay. Oh, there's the cat. How you doing there, Fritz? Meow. Meow. Okay then. And what we're going to do today is we're going to go over, I'm just more or less, going to read verbatim the Wikipedia explanation of Schrodinger's cat, and then talk about a little bit how this might apply either to reality, remember reality, Rich? Reality, calling Mitch Mitchell, reality. This is ground control reality to Astro Mitch. Can you read us, Astro Mitch? And then we're going to then discuss how Schrodinger's cat can be used in applications of observing and communicating using space-time travel communication coordinates in our space-time travel communication coordinate systems, which, as everyone knows, has two sets, and in which all representations of sixes are nines, and all representations of nines are sixes. And this, of course, applies to the letters F, I, P, S, and Z. Yes, me. And that also is the same grammar that we use in the BRE system, the Brutal Reality Examination System. Okay, once again. Okay, so what we're gonna do today is, well, let me introduce the title of this piece. Okay, so last time we had Act 1, which was Who Let the Cat Out of the Box, and then Scene 2. I think Scene 2 was called Oldest Living Senator, or just a thought experiment. And this time we're in the quantum superposition conversations. This is Act 1, Who Let the Cat Out of the Box. This is Scene 2. I think I said Scene 2 for last time, but that was Scene 1. Scene 2 is multiple outcomes in observation as communication space-time coordinate systems. Okay, so we're going to do that application today, and I'll explain, how it applies and how you can utilize it to create your even more complex space-time travel communication coordinate sets under certain conditions. Okay, and those conditions have to be met in order for there to be a quantum superposition of space-time travel communication coordinates. And not to let the cat out of the bag too early, or out of the box too early, but this can happen when there's a discrepancy between what the observation as communication says views, right, on the surface, as opposed to when you click the video and then it's a different number, right? You know what I'm saying? So that's like getting in that box and determining where that cat is really a number 8, or if it's a number 9 or a number 10. You see what I'm saying? And under those conditions, you can have, and we'll explain, ways that you can deal with those quantum superpositions that are created largely as a result of an error in what? Yes, an algorithmic error made by thermostat. Yes, the YouTube and or Google algorithm occasionally makes observation errors. Yes, indeed. And those errors record a phenomenon of views. And sometimes there's a discrepancy between what is recorded on one outcome and another. And so we're going to talk about that today. Okay, so following all that, Mitch? Got that? Mitch? Okay, anyway, so we'll go ahead and start by reading the Wikipedia description of Schrodinger's cat, and I may make comments as I go along if I feel those comments are necessary. Okay, in quantum mechanics, Schrodinger's cat is a thought experiment, not just the oldest living senator in the United States, concerning quantum superposition. Okay, and in the thought experiment, a hypothetical cat. Meow. He says he's not hypothetical. You can clearly see he exists in reality. That's kind of funny. Okay. Inside a closed box may be considered to be simultaneously both alive and dead while it is unobserved, as a result of its fate being linked to a random subatomic event. Now, this random subatomic event involves the breakdown of a radioactive material that will cause a flask of poison to be released in the chamber and kill a cat. And the chances of deterioration of this atomic radioactive element is a possibility, but not a necessity. In other words, given 1 hour, it may or may not emit, right, the proper amount of radiation to break the flask and kill a cat. Okay, all right, that's basically what they're talking about. We might clarify that more if they don't clarify later. That may or may not occur, right? Okay, this experiment viewed this way is described as a paradox. This thought experiment was devised by physicist Erwin Schrödinger in 1935. And we talked about Erwin Schrödinger and what he has in common with Donald J. Trump and Jeffrey Epstein and Bill Gates and Noam Chomsky and all that stuff. Okay. In a discussion with Albert Einstein to illustrate what Schrödinger saw as the problems of Niels Bohr and Werner Heisenberg's philosophical views on quantum mechanics. And once again, Mitch, the problem was, Mitch, you can't be, this is reality. Reality calling Mitch McConnell. Reality calling Mitch McConnell. Mitch, you can't be both dead and alive at the same time, just like that cat, right? That's not a hypothetical cat. That's a real cat. You got the hypothetical cat, and then you got the real cat. But in your case, Mitch, you got to make a decision. You got to choose whether you're going to be alive or you're going to be dead, okay? So if you're going to be alive, you got to show up for the meetings. You got to vote. You got to do all that stuff. You got to take your responsibilities. You got to, inform the public what's going on with your health. If you're going to be dead, just be dead, and then, you can't be a senator anymore because you're dead, right? Okay, so you get the idea, basically, right? Okay. In Schrodinger's original formulation, a cat, a flask of poison, and a radioactive source are placed in a sealed box. See, I'm in that box right now, but I'm not scared because this is just a hypothetical box. It's not real. Okay. If an internal radiation monitor, such as a Geiger counter, detects radioactivity, a single atom decay. The atom has to decay, right? The flask gets shattered, releasing the poison, which kills the cat. Okay. It's like a Rube Goldberg machine of death, mayhem, and destruction. Yeah. The flask is shattered, releasing the poison, which kills the cat. If no decaying atom triggers the monitor, the cat remains alive. Okay, so there's either a decay, right, of an atomic element, and then that breaks the flask and kills the cat, and or it doesn't because there was no decay. But the chances are pretty even within the time frame that the cat's in the box, right? Okay. If no decaying atom triggers the monitor, the cat remains alive. Mathematically, the wave function that describes the contents of the box is a combination or quantum superposition of these two possibilities. You got the live cat, the dead cat, and then Erwin Schrödinger formulates some combination of a cat being alive and dead, like this guy over here. But see, that's what we're saying. That's the paradox, and it points to the absurdity of such a formulation in relationship to material reality, because being alive or dead is a function of the material reality of the universe. It is not a system of science. Now, we're going to make this application in relationship to a system of science and interpretation and observation. Now, the wave function values in that system don't have to account for the physical reality of the system, right? Because it is a hypothetical system and it remains abstract, right? So the conditions of the physical universe do not apply in such an instance. Now, there certainly are, right? There certainly are an absolute real number of views. Like, say, you view this video this many times, or this many people view this video this many times, but we don't know what that number ever is going to be. Like, we have to trust thermostatin and thermostatin's ability to record those observations and those views, right? And then to record them accurately and in a non-contradictory manner. Now, when there's a contradiction in the recording system, then that's when we start getting interested in these multiple superpositions. Now, if everybody who ever looked at a contract and feed through Theta's YouTube videos and then give them a phone call, say everybody had a contract and feed through Theta's phone number, and they call them up and say, I looked at your video, I looked at this many times, and then as soon as you looked at something, you had to call, and everybody was honest, and we knew that, and the phones were in perfect working order, and there was no flaw in the system, then we would know the reality of the physical number, right, of views, and because that is part of that is the truth, that is a fact, right? So many people viewed this video or that video or whatever, but that's not the way it gets recorded, right? It gets recorded in a system, right, that we have to account for, that involves the algorithm's ability to count, right, and to measure, and to do so consistently within multiple sets of data and information. And we'll talk about examples of when it does that and when it doesn't do that. All right, okay, so let's see, where are we? Mathematically, the wave function that describes the contents of the box is a combination or quantum superpositions of these two possibilities. It either did emit, right? It either did decay or didn't decay enough to break that flash. Yet when let me see. Yet when one looks in the box, one sees the cat either alive or dead, not both alive and dead. Yeah, right, Mitch? Okay. This poses the question of when exactly quantum superposition ends and reality resolves into one possibility or another. Remember, we're talking about reality, Mitch? Okay, so that's the reality of the actual. Now, in applications, as I said, in applications to space-time travel communication coordinate views, the reality would be the actual number of views. But we never have access to that. We only have thermostatin's recording of that data. Correct? And that can either be accurate or inaccurate, or it can be accurate in one system and inaccurate in another, or it can be inaccurate in both systems. But we have to account, for all the systems under which the observations are created, whether they're accurate or inaccurate. And we're never going to get those phone calls. That's just not the way stuff works, right? So we're never going to get an actual reality of numbers of views. But we're going to get, more or less, what is recorded by thermostatin and interpretable by both contract and feed through Theta, and also a contract and feed through Theta's viewing public, right? Okay, yeah, of course. Let's see. Let's see, where are we? I lost my place. Yeah, okay, so when one looks in the box, one sees either the dead cat or live cat, and this poses the question of when exactly the quantum superposition ends and reality resolves in one possibility or the other, right? Okay, there you go. Although originally a critique of Bohr and Heisenberg, Schrödinger's seemingly paradoxical thought experiment became part of the foundation of quantum mechanics. It is often featured in theoretical discussions of the interpretations of quantum mechanics, particularly in situations involving the measurement problem. And we're going to talk about measurement today in terms of, measurement, a very simple type of measurement. It's called counting, okay? Let's see. involving the measurement problem. As a result, Schrodinger's cat had an enduring appeal in popular culture. The experiment is not intended to be actually performed on a cat, because it's a hypothetical cat, even though this cat is more or less real, right? Right, Fritz? Meow! Meow! Okay, and let's see, not performed on real, where was my placing it? Oh, boy. But rather as, not performed on a real cat, but rather an easily understandable illustration of the behavior of atoms. Indeed, experiments at the atomic scale have been carried out, showing that very small objects may exist as superpositions, but superposing an object as large as a cat would pose considerable technical difficulties. That's really funny in a lot of ways that I don't have time to explain right now, but you can laugh at that if you like. Okay, so fundamentally, the Schrodinger cat's experiment as how long quantum superpositions last and when or whether they collapse. Different interpretations of the mathematics of quantum mechanics has been proposed that give different explanations of this process, origin, and motivation. Okay, so Schrodinger intended his thought experiment as a discussion of the EPR article named after its authors, Einstein, Podolsky, and Rosen, in 1935. The EPR article highlighted the counterintuitive nature of quantum superpositions, in which a quantum system for two particles does not separate, even when the particles are detected far from their last point of contact, right? And we talked about that too. Quantum entanglement, that's a quantum entanglement problem. We talked about that once, earlier I didn't personally talk about it, but contract and feed through Theta has done work on quantum entanglement and also the context as well. Okay, so let's see. Where are we? The EPR article highlighted the counterintuitive nature of quantum superpositions, in which a quantum system for two particles does not separate. That's an entanglement, even when the particles are detected far from their last point of contact. Okay, the EPR paper concludes with a claim that this lack of separability meant that quantum mechanics as a theory of reality was incomplete. Okay, so Schrodinger and Einstein exchanged letters about Einstein's EPR article, in the course of which Einstein pointed out that the state of an unstable keg of gunpowder will, after a while, contain a superposition of both exploded and unexploded states. To further illustrate, Schrodinger described how one could, in principle, create a superposition in a large-scale system by making it dependent on a quantum particle that was in a superposition. He proposed a scenario with the cat in a closed steel chamber wherein the cat's life or death depended on the state of a radioactive atom, and whether it had decayed and emitted radiation or not. That's what we talked about. According to Schrodinger, the position taken by Bohr and Heisenberg would be that the cat remains both alive and dead until the state has been observed. That is, observation as phenomenon, right? Not observation as communication. And we're going to talk about the difference and why it matters, okay? In signification systems as opposed to phenomenal systems that bear upon the processes of the physical universe. All right, so until that state has been observed. Schrodinger did not wish to promote the idea of dead and live cats as a serious possibility. On the contrary, he intended the example to illustrate the absurdity of the existing view of quantum mechanics, thus employing reductio ad absurdum. Since Schrodinger's time, various interpretations of the mathematics of quantum mechanics have been advanced by physicists, some of which regard the alive and dead cat superposition as quite real, while others do not. Intended as a critique of ideas prevalent in 1935, the Schrodinger's cat thought experiment remains a touchstone for modern interpretation of quantum mechanics and can be used to illustrate and compare their strengths and weaknesses. Okay, very good. All that going on. Okay, so let's Mitch. I hope you don't mind, but I'm gonna cut away from us here. You mind, Mitch, if I cut away from us here? I'm gonna go to Contract and Feed Through Theta's YouTube channel and try to illustrate, how some of these mathematical ideas and paradoxes could apply to the interpretation of space-time travel communication coordinates and observation as communication. Do you mind, Mitch? Mitch? Okay, I'm just gonna assume that no answer is yes. Okay. All right. So, or it could be both no and yes, or no and or yes, or some combination of no and yes, I guess. All right. So here we go. Are we? All right, there we are. Okay, so we're at a Contract and Feed Through Theta's YouTube channel, and we're going to explore some of the ways that this problem, right, can arise in this system. All right, so we're going to start with this example. We're going to go to posts. Okay, now go to posts. And we're gonna scroll down. We seem to have lost some posts here. There's Mitch. There you are, Mitch. There you are, Mitch. You're right there. You're one of the posts. Okay, so here we are. This is what I was looking for. I didn't realize it was so far down. No, that's not it. That's not it. Oh, here it is. All right. Okay. So you can't tell from this, but you just have to take my word for it. Now, the reason that a contract can feed through Theta took this picture and this image. If you go up here, you see it says, "Seriously, thermostatin on? Do you really think you can substitute?" This is like a past, imaginary and or present something. And basically, it's the even more complex space-time communication coordinate number 68-26 with the even more space-time travel communication complex space-time travel communication coordinate number 6026. And so, what he's trying to say here is that the views recorded here, right, under video analytics, it says there were 68 views. But on the front page, right, and we'll go back to the front page and so you know what I mean by front page. But on the front page, it said 68. On the front page it said 60, right? It said 60, and then the next number was 26. Now the difference between 68 and 60 in space-time travel communication coordinates. So let's just go to space-time travel communication coordinates and show you what that difference looks like. All right, so we're gonna go to the music playlist. Here's our music playlist. All right, and I gotta position this up here now. And as everybody knows, there's 36 units from top to bottom if I position this correctly. Okay, so that's we'll go down here. That Billy Bang, that's the 36, and then we'll do another 36. That takes us to 72, and then okay, so Delbert Black Horse is 72, and then we're gonna go 7. One. No, I'm sorry. We're gonna count. We're gonna subtract 12 from 72. That's gonna go to 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So and it was different before because we were doing something different. But anyway, so Huang Vu, this is 60, right? Oh yeah. Oh, made a mistake. Okay. Part of the grammar, right? Part of the grammar is that part of the grammar in this system is that all 6s are 9s and all 9s are 6s. So 60 actually has to be 90. So let's add 30 to this, and then we'll get the proper space-time travel communication coordinate. All right, so then we just added 36. Now we gotta subtract 6 again. 1, 2, 3, 4, 5, 6. And that's Faust, okay? So and then we'll go down 26. What's 20? Let's see how many there are in this set. All right, anyway, so let's go. Now in this set, from top to bottom, that's 18. That's 18 right there. And then we gotta get to 26. So we're gonna add 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the space-time travel this is the space-time travel communication coordinate that Thermostatin was saying that we had at the front of the page. All right, now the other one is 68, which we translate into 98. So we'll go down 8 more. 1, 2, 3, 4, 5, 6, 7, 8, and that would be Gil Scott Heron. And then we go to 26. Let's see how many there are in this set. Oh, 65. Okay, so let's go down 18. That's 18. Plus 8. Oh, no, I think I made a mistake. That's 26. So we got to go back to 29. Okay, so 26. Don't forget that grammar. We made that mistake. Okay, so where were we before? Does anybody remember? That's it, right? So 1, 2, 3. Okay, so that's actually the number that they were talking about. Now we got a lot of 6s and 9s. You got to remember to factor those 6s are 9s and 9s are 6s in. Okay, so that's the number for Faust. And then we go down to and we got to remember it's 29, not 26, because if 6s are 9s and 9s are 6s. All right, so where were we again? Gil's got hand, and then 29. Okay, so that's 18. And then that's 36. 1, 2, 3, 4, 5, 6, 7. See? Okay, so that's and this is what it says in the analytics. You see? This is the space-time travel that's recorded in the analytics. Now, you do not have YouTube viewers, right, and subscribers to a contracted feed through Theta do not have access to video analytics. That belongs to only, you can say, put it this way, if this was the box that the cat's in, only a contract and feed through Theta can open this box, okay? So, you can't open this box, and this box can only be opened by a contract and feed through Theta. Now, if a contract and feed through Theta opens this box, and there's a discrepancy, and a contract and feed through Theta wants to communicate that discrepancy to the viewing public of a contract and feed through Theta's YouTube channel, then a contract and feed through Theta can do so with something like this, you see? Something like this. And then you have access to that information. But if that doesn't occur, you can't see whether that cat is alive or dead. Or, like, let's put it this way, whether there are, in fact, quantum superposition multiple outcomes in observation as communication systems. You understand what I'm saying? Okay, let's go back to the front page. Okay, we're back on the front page. Now, occasionally, right, and this is what makes it tricky. All right, so, I'll explain why it makes it tricky. Okay, so it says 16 here, which is 19, right? 19.8. Now, we're going to go ahead and click on it and see if the 16 says 16 on the inside, because sometimes it says 16 on the outside, but then you click on it and it says a different number on the inside. Okay, now if that's the case, you have this paradox, because in order to determine, like, if there's a discrepancy, you have to click on it. Well, clicking on it may change the 16 to the 17. You understand what I'm saying? So you click on it, and then do you change it by observation, or do you not? And that's where this this lag and delay and discrepancy in the algorithmic counting system that Thermostatin performs for Google and for YouTube gets in the way of things. Now, say that this was 17 on the inside, but if you don't click on it, you're not going to know that. So it's going to remain 16. So if you don't click on this box, right, it's going to remain 16, right? And that's actually 19, and let's say 19.8, right? Let's just use that as a number, because it could be 198, 19, right? 180, there's all different kinds of possibilities here. 198, 19. but I'm just going to use 19.8. Okay, so let's go to 19.8. All right. Let's see. So 19. Well, we know that Angela Davis is number 12. So go 7 more. 1, 2, 3, 4, 5, 6, 7. That's Archie Shep. And then you go 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's back, back. Okay, so that's what we got for that coordinate. Now, I'm going to click on it. Now, we don't know whether that number is going to be the same or whether it's going to be different. You know, and we don't have to look. We don't have to look. We can just use this number. But let's say we click on it. Look at that. It's 19. Okay, it said. Look at that. Look at that. Okay, it says 16 on the outside, but it says 19 on the inside. Okay, so let's go back up to 16 because 6 is 9, so 9 is 6 is 1, 2, 3. So we got this is exactly what I was telling you about. Okay, so we got these possibilities, right? We got 19 and 16. All right. And let's see. And at 19 and 16, and then 16 is 8, 1. Let's go over here. 1, 2, 3, 4, 5, 6, 7, 8. So we either have this number right here. That's a difficult one to deal with because Anthony Braxton, his titles are complex, and unless you know what's going on all this stuff, and it makes it a little difficult to determine. But it's still a possibility for communication, right? Okay, so this is 16.8, and we also had 19.8. So you're getting the idea, right? Okay, so let's go figure out. So we have multiple possibilities. So we clicked on it, and now we have a 16 and a 19, and that's a superposition. So you can choose one of those, and you can say the cat is either 6-77AR-36K opus 23B, or the cat is back, okay? And then there may be other ways to do it. Like say, okay, let's get out the calculator. Okay, we get the calculator. And okay, so let's clear that. Okay, so we're gonna put 16. Because remember they said alive or dead or some combination of the two, right? So like Mitch, like that zombie state of the combination of the two. Okay, so 16 plus 19 equals 35. Okay, so that's a combination of the two. Now, do we want to divide that by 2, or do we want to just leave it, right? If you divide it by 2, it's going to be interesting, because then you're going to have a half coordinate that exists between some coordinate and some other coordinate. So I'm thinking that's going to be 17.5. Let's go ahead and see if it is. Divided by 2 equals 17.5. So what's 17.5? Well, that would be 17, and that would be 18. So it can either be Anthony Braxton, or it can be Archie Shep, or it can be somewhere in between these two, and then be number 8. And I don't know how we're going to deal with that. Because that being alive and dead at the same time, I mean, it'd be a lot easier. Like, okay, let's just say for hypothetical and theoretical sake that it was 20 and 16, right? Not 19 and 16. Let's just clear this. And 20 and 16 is 36, right? And that would give us 18. And then so that's 16 right there. So no wait, that was 16 right there. No wait. No, yeah, this was 16, 17, 18. So, if it was 20 and 8, like let's say it was this one and this one, then you'd have an option over here. 1, 2, 3, 4, 5, 6, 7, 8. Armenian, Obsidian, okay? But being in that half state, between, this is like being alive or dead. You can only do it on the even ones, because there's no intermediate, between. So 17.5, right? Is that's somewhere between Anthony Pirogue and Aram Bajakian, and there is nothing in it. You see what I'm saying? Like, do we really want to make it 35? I don't think we want to add those things together, because then you could say, if it's the same number, you could add them together. What if it was 16 and 16? Then you could say it was 32. So everything would have to be double. Everything would be itself and a double of itself. So I think we got to divide it. So let's just say it this way. Okay, so here's how we're going to do it. Okay, so we got a situation like this. Then you can use the 16 or you can use the 19. But don't forget, 6s are 9s and 9s are 6s, right? Okay, and then you got a situation like this. You can use either one. Well, let's say you can add them together, right? Okay, so you got two possibilities. If there's a discrepancy. If there's a discrepancy on the inside and the outside, let's go back. If there's a discrepancy on the inside, 16, and the outside, 19, then you can use both those possibilities for your communication coordinate responses and messages to a contract and feed through Theta. But that means that you got to click on that box, right? So, like, depending on whether you click on the box or not, you're gonna get, you're gonna have a different sense of your possibilities. All right. Now let's also say that if there is a discrepancy and half of the discrepancy is an even number, let's say you can add the two together and divide by 2, right? So in this case you can't do that because it's an odd number. But if it were an even number and it were 18, right? You could do 18, 8, right? And okay, now let's go on to this one. Let's see if there's a possibility in here. Let's go ahead and click on. We're gonna click on Little Mitch in the box surrounded by cosmic daisies and see what goes on. All right, okay, ready? Are you ready? Hey, it's me, Turkey. Okay. Let's see. Oh no, that's 8. Okay, so the 8, it remains an 8. But if it were a different number, let's say it was a 6, right? Let's say it was a 6. Then you could do 16 and or 19, and then you could do 8 or 6 or 9, because 6 has become 9, right? Oh, this gets kind of complicated. So say it said 6 right here. Then you could do 8 or 9 or what? Add. Let's see. Well, that won't work. Yeah, it will work. Let's see. So let's say it only becomes 9 when it becomes a space-time travel communication coordinate. But if you're going to add them together, it remains a 6. Okay, so add them together and you get 14, right? 8 plus 6 is 14. So half 14 is 7. So you'd have 8 and 9 and 7. All right, so let's go to, let's just do the first one, which is 16 and 8 and 9 and 7. All right, so 16 is 19. So where were we again? That's Archie Shep, right? Because the 16 is 19, and we got 8 and 9 and 7. So 7, 8, 9. 1, 2, 3, 4, 5, 6. Now this isn't a possibility because it didn't say 6. But if it did say 6, this would be a possibility. We have come back part 1, back, and Snoopy-Doo. Snoopy-Doo. Okay, see how that works? That'd be 7, 8, and the 6 becomes a 9, right? That's Snoopy-Doo. If the 6 didn't become a 9, we could have Brotherhood at Quechua. We have come back part 1 and back. All right. So those are the applications. So pretty clear, right? Pretty clear. And that's me. I'm gonna go back. Well, I don't think we need to look at the front page anymore. I think that explains it. So did you get all that, Mitch? And do you understand why that it works that way and it's different if it's reality versus a recording of made by an algorithm of that approximates the number of views that actually occurred that weren't phoned in to a contract in P through theta? So we're not talking about the reality of views, but rather what was observable by an algorithm and then recorded by an algorithm within a space of superpositions and multiple outcomes. Do you understand? Okay, Mr. Stone isn't talking about how about you, Fritz? Meow. Meow. All right. Once again, Miss Turkey. I think that's all for today. So enjoy the new possibilities of observation as communication in the quantum mechanics of thermostatic error. I guess you could call it something like that. All right. Okay. Have a good day, or if you prefer, have a nice day.